let's welcome Scott Amyx, the managing partner for Astor Perkins.
Great. Thank you so much for that, Florin. So much of today's climate action rhetoric is around reaching net zero. But what does that mean, and is that enough? Even if somehow we're able to reach net zero emissions, this does not necessarily mean that the CO2 levels in the atmosphere will fall. Switching over to electric vehicles alone isn't going to remove what's already in the atmosphere. We have to proactively remove carbon and other non-CO2 greenhouse gases from the atmosphere. Both on the emission side as well as on the carbon removal side, we need massive global scale solutions, and we frankly don't have time. Looking across many research models, combining different scenarios suggests that the best estimate of the effects of zero CO2 is around 0 to plus or minus 0.3 Celsius for the century after emissions go to 0, while the effects of non-CO2 greenhouse gases and aerosols, if you were to go to 0, would be around negative 0.2 to plus or minus 0.5 Celsius. In other words, even if we reach net zero emissions, global temperatures are expected to remain steady for several centuries, meaning that the climate change-related natural disasters like severe wildfires, drought, and hurricanes are going to continue, and the economic and social political impacts will be felt for generations to come. At Astor Perkins, we back mavericks solving some of the hardest problems facing humanity on Earth and space. But what we look at especially is if a solution can scale globally and become the number one or number two dominant market leader in a new industry. It's all about scalability. GA drilling. GA drilling recognizes that scaling solar and wind will not be enough to meet the growing demand for electricity and heating. One of the most ubiquitous assets that covers 70% of the globe is geothermal. Yet today's conventional drilling is not able to cost effectively tap into that energy source right under our ground. GA drilling is making it possible to scale clean energy in a cheaper and reliable and scalable way that helps us to be energy independent. Solar foods. We recognize that no matter how much people understand the benefits of plant-based diet, people around the world cannot get enough protein. YouTube is full of them gorging on meat. Almost seemingly out of science fiction, Solar Foods is able to make pure protein out of thin air. No animals, no land, not even cells in labs. They use electricity to produce hydrogen, which is then combined with carbon dioxide, water, vitamins, and minerals to then feed a microbial biomass that becomes edible protein powder. And this in turn is used as a protein ingredient in food production to satiate our appetite for protein. And the best part is that this solution is scalable, whether it's global regions affected by drought, flooding, or other extreme natural disasters. Allura Quantum. Solving existential threats will also require new forms of computation, such as quantum computing. Yet there are so many different approaches to quantum computing, and many are struggling to surpass hundreds of qubits. For quantum computers to be functional and revolutionary, the number of qubits will need to scale to millions. And that's where Allura Quantum comes into the picture. Agnostic of the underlying hardware stack, they're working to create quantum networks, much like distributed computing or grid computing, in such a way to make scaling millions of qubits possible, regardless of the quantum computing models. Voyager Space and nanoracks. Human survival in space is paramount in order for us to explore deep space. We read about the latest SpaceX launches or the private space crew on Axiom 1. truly the space economy is growing into a trillion-dollar market right in front of our eyes. And in the next few years, we'll see a robust private space station market. Voyager Space and their company Nanoracks will share their plans to replace the aging International Space Station with a privately operated Starlab space station. Lunar Station. Sending payloads to the moon is more than just about science experiments. Surviving and succeeding in space will depend on finding energy, raw materials, and establishing a depot on the moon. Think of it as a gas station, a hotel, and the natural resources and the building materials needed to explore Mars and deep space. Lunar Station Corp is enabling the discovery of lunar ice for oxygen and hydrogen, mining deposits, and rare minerals for building infrastructure. And they're providing the critical data analytics and intelligence to help ensure lunar missions are successful. Potential motors. Solving the hardest problems facing humanity on Earth and in space will require AI, robotics, and automation. And specific to the area of transportation, these companies are trying to solve the scaling issue in electric and autonomous vehicles. Instead of focusing solely on passenger cars on roads, they're investing in off-road autonomous vehicles to reach critical scale. From off-roading for recreation to farming machinery to rovers on the moon, Potential Motors, Hyundai Motor, and Boston Dynamics are working on smart, autonomous, and safe off-road vehicles and robots at scale. At Astor Perkins, we conduct due diligence on deep scientific and technical startups to isolate winners solving the hardest problems facing humanity on Earth and in space. We are not interested in novel science projects, but rather revolutionary and globally scalable solutions that can usher in the new mega industries of today and tomorrow. With 4 potential exits in the near horizon and many more investments to be announced, Astor Perkins is excited to feature these brave mavericks who are trailblazing to bring global scale in their respective fields. Welcome to Astor Perkins, all things deep tech and survival. Back to you, Florent.